And my boy Louis Pasteur, right, makes this thing called the swan neck flask, has the broth in it. What's really cool is when you boil it, moisture gets trapped in the curvature of the neck, right? That moisture traps anything from the air. You turn it on its side, liquid hits that that section of moisture that has the particles wrapped in it, and then you get growth, right? And so this proved that bacteria, right, and other infectious agents were coming from the air, right? They weren't just appearing out of nowhere, right? We'll talk about it here in just a second, some other kind of important figures. Again, I know to us this kind of seems simple, but this was a really big deal, all right? We're talking, the early 1900s. People are still not convinced that hand washing is necessary between seeing patients and that sterilizing instruments is needed. All right, so there was definitely slow progress here. All right. So this kind of goes back a little bit to Abby's point, right? Some people would boil broth, it would be sealed really well, and things would still grow, right? And so this is kind of our first indication that there are organisms that are resistant to heat. All right? And so what John Tyndall does is he focuses extensively on boiling for different amounts of time to try to kill these organisms. And then my boy Ferdinand actually discovers something called an endospore. We'll talk about these maybe periodically throughout the semester, and we'll really focus on them in the end. Endospore is basically a bacterial seed. And again, that's not, please don't write that on your exam, right? But to kind of give you context, these endospores are resistant to heat. They're resistant to dry environments. They're resistant to wet environments. They're resistant to cold environments. All right. Have any of you worked at like hospitals as CNAs or done any of that stuff?
I'm a CNA, but not at a hospital.
Not at a hospital, okay, but you're a CNA, right? So have you had any folks wherever you're at that have dealt with C. diff? All right. So if you've heard of C. diff, right, Clostridium difficile, it causes very, very, very bad diarrhea in patients, and you may be thinking, well, what's bad about that, right? Think about someone that's 80 years old having really bad diarrhea. When you have bad diarrhea, what do you lose a lot of? Fluid, right? You can't have fluid balance, so it can actually be deadly. And it is caused by a bacteria that forms an endospore. And one of the things that makes it so hard to treat is, well, we'll talk about when you give those patients antibiotics, right? It's caused by a bacteria. So what happens is it causes these bacteria to freak out, rightfully so, and they actually start to form endospores. The infection clears because you've killed the bacteria, but their little endospores are left behind, and then they have a reoccurrent infection later. Right? Anthrax, right? If you've heard of anthrax being put into a powder form, it is the endospores that are put into a powder form. These endospores can survive potentially up to hundreds of years depending on the bacteria. Right? So a really kind of interesting mechanism that they use. And then if someone can give me a heads up, I'll have you hold me to this. When it's like 8:45-ish, we'll end early, right? Because one of the things I forgot to mention is you now have to go grab a white thing. That's like thinking baby wipes. I have a toddler at home, and I'm like, those are a little different. And you just have to kind of wipe off your desk area and your chair. All right? Breathe. So these two gentlemen, right, Jacob Henle and Robert Koch are kind of up there with Louis Pasteur. They really kind of harp in or hone in on this idea of it's microorganisms that are causing disease, right? It's not bad luck. It's not gods, right? It's not black cats, right? It's microorganisms that are causing disease. And again, it took a lot of time to convince people that this was the case. These are Koch's postulates. although slightly dated, they still hold generally true, right? These are important kind of steps for officially linking a disease and a microbe, right? So the idea would be, right, if you guys all in these middle rows, right, we're all sick, and then I isolated the same microbe from them, right? And then I would take that microbe and now I would inject it probably into an animal to see if I induce some type of disease, and then I would re-isolate it, right? It's a pretty kind of stringent, actually, list of steps that allows you to officially tie that disease and that microbe together. Interesting historical example of this would be in the 1918 flu pandemic, right? There was actually a lot of debate as to whether that was being caused by a virus or by a bacteria. A lot of the patients that were succumbing to that strain of flu also had, right, a certain bacteria present in their lungs, but not all of the patients had that bacteria in their lungs. And so that was an example of the Cox postulates being used to say, hey, no, it's actually this virus, it's not these bacteria. We're going to talk about this later. Don't worry about this, actually. This is actually a really kind of interesting chart. I tried to find one that came another 20 years out to see this. I haven't found one yet that's good, but what I do want you to appreciate is these are deaths in the United States from pathogenic disease, right, over about a 100-year period. And what you can see is a general decline, right? What you have up here, right, is the 1918 influenza pandemic, which caused a big spike. Other than that, right, you can see a gradual decline, and you can see a number of things that have been introduced. Public health departments, right, chlorinating the water, right, the introduction of antibiotics, the introduction of vaccines, have all caused kind of a steady decrease, right? You do see some small blips. We will likely have another blip during this pandemic, but to give kind of context to the 1918 flu pandemic, estimated low end that it killed 20 million people worldwide. High estimates tend to go towards 50 million. You think about the world population, it was significantly less. It's estimated that up to a third of the world was infected with the influenza virus during the 1918 pandemic. So I think it's kind of important to have context. This is a very serious pandemic that we're experiencing right now. But as of yet, and again, I could be wrong, it hasn't quite reached this magnitude. Okay. Yes, ma'am?
Are pathogens, is the only thing that's different than that is that includes like viruses and things like that versus?
Yeah, well, so that's actually a good point. I didn't make that distinction, right? So all pathogens are microbes, right? Not all microbes are pathogens. And so I'm actually glad that you brought that point up. One of the things that I will try to point out, and sometimes I get kind of caught up in disease things, and we will talk about this sometimes in the context of the gut, is there's a lot of microbes that do a lot of very good, important things. Right? We have a tendency to focus on pathogens, but if you look at the percentage of microbes that are pathogens, it's actually a very small percentage. Now, that small percentage can have a large effect, but yeah, that's the distinction there. So thank you. I totally glanced over that. I know this is hard to see, but if you look at the PowerPoint that I'll put up on Moodle, this is actually a list of notifiable diseases. We'll talk about this probably sometime within the next couple weeks. The CDC and the World Health Organization have notifiable diseases. So when you go into the doctor and you know, they pull your sample and they're like, oh crap. Can you tell me your name again? Rachel. Rachel has mumps, right? Well, that gets reported to the CDC because they want to kind of keep track of that. Now, truth be told, Rachel hopefully shouldn't have mumps because she got her vaccines. But we'll talk about a little bit the anti-vaccination movement. If you actually look at some of these numbers over here, there are blips where they've gone up. All right. So So again, modern medicine, modern vaccines, if you look generally across the board, you'll see a decrease in some of these diseases, right, because of advancements that we've made. Interestingly, I'm trying to, some of the, STDs, I'm sorry, STIs, that's more, I guess, correct these days, sexually transmitted infections, have gone up, and some other diseases that we had pretty much eliminated because of vaccines have also seen a small uptick. Here you have emerging infectious diseases. A kind of rough definition of this are things that are kind of things that have popped up within the past 30 years. Now, it doesn't necessarily mean that, again, spontaneous generation is not a thing, but for some reason, right, and COVID is a great one, right, we think that there were multiple animals together in the wet markets in Wuhan, right, they were in close proximity. So you have zoonotic diseases, right, that then made the jump from those animals to humans, right? So it's not that, coronaviruses are new or necessarily novel, but the state that they're presenting themselves in is novel. So you can see kind of a number of different things here, right? If you've been paying attention to this pandemic, or if you've not been paying attention, but if you read into it, right? So some of you, you would be pretty young when this happened, but heard of SARS, right? And so SARS-CoV-1, right, or just SARS-CoV, is a coronavirus that caused SARS. So this virus's actual name is SARS-CoV-2. So they are very closely related. We can see that the rate that they cause infection is really different, right? But those are both out of China, right? You do see kind of some things come out of the subtropic area, and they're not necessarily, just because they're labeled doesn't mean they came from there, right? So here you see 1981 AIDS in the United States. Well, we know enough about the HIV virus that did not come from the United States, right? But that's when it kind of emerged or presented itself there. These, and I'm not going to take time on this because I want to try to fit in one more slide, are examples of current event articles that you can click on and you can see. The top one is about cases of plague in national parks out west. I recently heard that I think someone died of the plague in California, which is like our first plague death in the United States, I think, in a little while. But there's still a few cases in the U.S. every year. This was a cool article that a student had found showing that Alzheimer's may actually be caused in some patients by bacteria. So they treated these patients with antibiotics and reversed some of the symptoms of Alzheimer's. This last article, which I think we can read the top of it, is basically modified E. coli that digest products of landmines and then fluoresce, and then you shoot this area with a laser, and the laser reflects off of where the E. coli have found landmines. Right? So there's all different types of things that you can look at. This will be where we end, and then I'll let you guys go so we can do our cleaning procedure and get out of here on time. But, kind of to the point that Blair raised when she noticed my slide, these are the good things, or some of the great things that microbes can do for you. So nitrogen fixation, carbon fixation. Michael, what's nitrogen fixation and carbon fixation?
I don't know what to explain it, just like acquiring nitrogen carbon from line.
Okay, well, yeah, that's good. So I can work with that, right? So if you guys remember from way back when, atmospheric nitrogen and atmospheric carbon, right, can't be used by you to make organic carbon and organic nitrogen, right? So nitrogen that's found in nucleic acids found in proteins, right? All the macromolecules that we care about for life are carbon-based, right? When you breathe in, you bring in CO2 and you bring in nitrogen, but your body can't utilize those, right? So they have to be converted, right? One of the reasons you can't do that, and we'll talk about this a little bit more to the end of the semester, is they require an insane amount of energy, right? Nitrogen gas, right, or atmospheric nitrogen, has a triple bond, right? Some of you may have totally forgotten everything about chemistry. I get it. wasn't a chemistry whiz either, right? But I think you can appreciate triple bonds, right? The more bonds you have, the more energy, so we just can't do it. Microbes can do it, right? And so we benefit from their ability to do this. Photosynthesis, not surprising to you guys, hopefully if you think about it, photosynthesis is a way to make easy and abundant energy. And so typically organisms that are capable of fixing carbon and nitrogen often are photosynthetic, not all the time, but a lot of times. Decomposition, right, breaking things down, all right, returning those nutrients to the environment. Fermentation, all right, we'll talk about this more later, but those of you that like cheese, pickles, sauerkraut, cured meats, hot sauce, there are other things that are fermented that we don't talk about here at Lee. All right, that have been important in the history of the world, right? And we're using microbes for those. Ooh, I'm making bread right now, my first batch of sourdough, right? So I have a culture going right now that's relying on yeast and other bacteria, right, to push that process along for me. Bioremediation, right? What's really cool is we found microbes that are actually great at eating oil. And so, you remember what was the BP Gulf incident? One of the things they did in some areas is they basically sprayed bacteria on top of those oil spills to help break down the oil. We have also found bacteria and fungi that possess enzymes that can break down plastics. And so that's kind of cool. And then digestion, right? You have bacteria in your gut that help you break down certain food products. Organisms like cows, termites, right, that are ingesting and breaking down grass, maybe ingesting and breaking down wood. Right, they're doing that because of the microbes that are present in their system. All right, so that's going to be where we end. We don't have much left here. I'll finish that off, and then we'll actually start with some epidemiology. All right, please, in kind of an orderly